When you download code to run on your Arduino, the inputs and outputs that are available to you are those that are connected to the Arduino, LEDs or potentiometers. You may need to communicate in a more sophisticated fashion with the Arduino. Perhaps you'd like to get some text back or have it report a number back to you. This is very common in debugging, where you use a sensor and you read some value from it, and you'd like to just know what the number, the value of that number is. So it turns out one of the most common libraries that we use in running the Arduino is a library that can communicate between the Arduino and, let's say, the computer that you've connected it to over the serial port. And you might be thinking, well, what's the serial port? You're using it already. The S in USB stands for serial. It's Universal Serial Bus. And when you connect your Mac or your PC to the Arduino with that USB cable, you can communicate back over that cable to your desktop computer and have a screen where, for example, you can print out text and values and things. So it's super, super common. And so I'm going to show you how to use that today. So the first thing you need to do in the setup part of your sketch is begin the serial connection. And so there's a command, serial.begin. Serial is the class, if you know object-oriented programming. So all commands that use the serial library will begin with serial dot. And then one of the functions you can call, all these documented in the Arduino software page, is begin. And the argument it takes is, how fast would you like to talk over this serial communication port? And serial just means there's a single wire and you're taking the voltage up and down. And the units of this are bits per second, which is 3 words. And in engineering, we like shorter things, so we call that baud, B-A-U-D. It just means 9,600 bits per second are going to fly over this line. And that's a pretty standard value, and you can just choose that. So you initialize the serial communication, you tell it how fast we're going to talk. So that exists in almost all setup sketches because it's such a common thing. So I just took the blink program, blinking the internal LED. So I'm writing a digital value to high, then delaying, then writing a digital low to the LED built in, then delaying. But I added a couple little things. Up here at the top of the code, outside either void, either setup or loop, I added an integer called loop count, and I initialized it to 0. By defining and declaring that integer outside of either program, it's available to all of them. It's universal. It's a global variable. It starts at 0, so down here in the loop, I add 1 to it every cycle, and then I use the serial print command to print the text loop number, and a second command to print this variable, and I end that print command with ln, which says is line. It's print line. It means it puts a carriage return. It restarts the line every time I run it. So let me run this program. We see that it worked. And up here under Tools, I will bring up the serial monitor. And there's my program running. Loop 1, loop 2, loop 3. Every time the loop runs, I see a new line show up on the serial monitor, and the numbers going up. So the LED is blinking at a couple hundred milliseconds, so at the same rate. And this is just super valuable for now to go in and say, tell me what you're doing, report that something's happened, give me the value of a variable. Sometimes this is the way your program would report its data back out to a user, is here's the data you asked for. A lot of other times it's just you use that for monitoring or debugging the operation of your code. Very simple, super useful.